Hi there, guys. We're going to try some harder concentration problems, maybe give you a hand with some of the questions on the assignment that I gave, or you're just looking at tackling some of the ones that are harder than the other examples I gave in my other videos. So here we've got three different examples, and in those examples you see concentrations. In example 1, there's a concentration given in percent weight to volume. In example 2, there's a concentration given in parts per million, and in 3, again, we're in weight to volume. So our concentration formulas we've seen in the past are either the concentration is in moles per liter, which is N over V for moles and liters, or our other formula that we've seen is concentrations where they have to be in mass over volume. And the reason that we needed mass over volume is percent WV, as you've seen in our other videos. You need to have your mass in grams and your volume in mils, and for a percentage you'd multiply it by 100. So automatically a 12% weight to volume is 12 grams per 100 mil, and we'll do that in the question. Parts per million is also a concentration in moles, or in mass and volume, because you're dealing with a mass that would have to be in milligrams and your volume in liters. And I'm doing this quick because you've already got videos that show you how to work with those. So we'll take a look at example 1. We have a 150 ml solution. 150 mils is our volume. So 150 milliliters. This concentration, 12% weight to volume, that's concentration. 12% WV is equivalent to 12 grams per 100 mil, which is, when you divide it, 0.12 grams per milliliter. Now, what is the question asking for? The question's asking for what mass of solute, M, is our unknown. Concentration is mass divided by volume, so when we rearrange that equation, we know that mass is equal to concentration times the volume. Our concentration is 0.12 grams per mil, and the only caution you have to have is that your volume better be in the same units of milliliters, and they are each. They have mils. If one was liters and the other milliliters, you would have to deal with that. So you have 0.12 grams times by 150 mils, and this was grams per mil. We'll bring up our handy-dandy calculator, and we have, clear this off, 0.12 times 150 gives us 18. Of course, you could have done that in our heads, right? And the mass would be 18 grams. So that is the mass of solute that would be in that question. So we'll go back and take a look at example number 2, which says what volume of 150 part per million solution, this is our concentration. Concentration is 150 ppm. Question wants to know what volume, so that's our question, has 25 milligrams, that is a mass. Well, before I start thinking about whether I have to change my mass of milligrams to grams, we need to consider what the ppm is. That is 150 milligrams per liter. So that indicates to me that I see milligrams here, milligrams there. I'm going to be able to use those two concepts together without having to convert any units. Again, my main formula, C equals M divided by volume. To rearrange for volume, you would have V equals M divided by C. So we take our mass, 25 milligrams, divide by a volume, or a concentration, excuse me, of 150 milligrams per liter. And 25 over 150 would be 1 over 6. So you get 0.1666, repeating for a long time. The milligrams cancel, and this liter is going to come up top, and that would be your answer in liters. So if we were rounding this off to 2 decimal places, or 2 significant digits, you'd say 0.17 liters is the volume, which might even be better to write it as 170 milliliters, where you'd multiply by 1,000 and make it a bit more pleasing unit to look at. I've got lots of time, so we'll take a look at our third example. The third example is a 150 ml sample of 10% weight to volume saltwater solution has how many moles? Again, 150 mils is my volume. My concentration is 10% weight to volume. And I want to know how many moles I have. Well, in this question, as soon as I see 10% weight to volume, we saw in the last question, that's 10 grams per 100 mil, which of course 10% would be 0.1 grams per mil. And here I have milliliters. As soon as you're using percent weight to volume, your concentration is mass over volume. This question wants moles. So we can't just use M over V and get an answer. You have to get mass, and then we need to look at our formula for N is equal to mass and molar mass. So we'll have to use this guy afterwards and rearrange them to get our question done. So we'll first solve for mass. M equals C times V. Mass is equal to the concentration, which is 0.1 grams per mil. Should make this pretty easy to do. Volume of 150 mils. Milliliters cancel and gives us a mass of 15 grams. So that means I have 15 grams of salt in my saltwater solution. Our salt is NaCl. So to get the number of moles, I have my mass of 15 grams. I need the molar mass of sodium chloride. The molar mass of sodium is 22.99. The molar mass of chlorine is 35.45. When we add those together, you get 58.44 grams per mole. That means if you were to assemble 1 mole of salt salt molecules, it would have a mass of 58.44 grams. So we are now ready to figure out how many moles of salt you have when you have 15 grams. 15 grams of salt, divide by 58.44 grams for each mole, would let us determine how many moles we have. So we need to take 15 divided by 58.44. Turn this back on. It's timed out on me. 15 divided by 58.44 gives us 0.257. 0.257 moles. And so we check that we've answered our question. How many moles of salt are there? There's just over a quarter of a mole of salt, 0.257 moles. Looking at significant digits, I see 2 digits that matter here, but only 1 there. So really, if you were to round this off to 1 significant digit, you'd round it all the way off to a 3, 0.3 moles. But the method is really what's crucial there. Hopefully that helps you with your assignment or with any problems that you're having.